Okay, so today's talk that I have put together is Rigor Starts with Reporting, Lessons from a Decade of Dietetics Research. So, interestingly enough, the speakers that I have today are more than relevant for my talk because in 2021, um, Dr. Holly Shafsma, who at the time was a master's graduate student, was co-supervised by myself and Dr. Jasna Tweinstra, the other speaker. And Holly, along with another Holly, just by chance, Holly Shafsma and Holly Lassinen, the two of them were graduate students in food and nutritional sciences, and this is something I that both Dr. Tweinstra and I both really wanted to do. We wanted to have two outstanding grad students at the same time that could do a project and undertaking like this. And what we did is we looked at the Canadian Journal of Dietetic Practice and Research, which is basically the Dietitians of Canada journal. And we looked at every single paper published that was quantitative or mixed methods that had a quantitative component over the course of 10 years. And we looked at how they're doing in terms of their statistical reporting. I'm going to tell you more as the slides go on, but that's basically the context of where I'm going to go with this. So, many peer-reviewed articles contain statistical and methodological errors that are large enough that they call into question the author's conclusions. This means that many research articles, not just in nutritional epidemiology, but in all fields for that matter, often pass through the peer review process without an adequate statistical review. And one reason for this, there could be many, is that many editors and reviewers, for that matter, lack the expertise to provide a thorough statistical review. So Dr. Tweinstra and I co-teach nutritional epidemiology grad course here at Western. And one of the things I often ask is, what is evidence-based practice? And it's interesting because everybody seems to know a lot about what that is, but yet when I ask the question, the answers are all over the map. And I say that if you don't truly understand methodological rigor, the purpose of this special issue, or whether the statistical tests are actually correct or not, or adequate or not, or how to interpret your findings, what are you want me to stop there? Okay. What are you really basing evidence on? So if it's just, the article reads well or the findings coincide with what I believe, that's not truly evidence-based. Evidence-based is you know how to set up your study design, you have an appropriate sample size to actually test a hypothesis, and you know the adequate statistical tests that are appropriate for your given research project. So what can we do? Well, one strategy to enhance statistical standards is to have a checklist on a journal's website that authors can use prior to submission to make sure that they're following adequate statistical and/or methodological reporting. And this would streamline, I would argue, the review process for the editor prior to the manuscript being sent for peer review. I can't tell you how many times I got asked to be a reviewer for many journals, and I wish it would have gone through a kind of internal review prior to being sent to me because of all of the, statistical errors, for example. So here's what we did. Our research team evaluated the quality of statistical reporting and procedures in all original articles published in the Canadian Journal of Dietetic Practice and Research from 2010 to 2019 using a checklist created by our research team. And you'll notice the two people there. Um, we never age. Just kidding. That is Dr. Tweinster and I, and we were the co-supervisors of this project, as we mentioned before. So all original research published from 2010 to 2019 in the Dietitians of Canada Journal was assessed for adequacy of statistical reporting and the correctness of applied statistical techniques. And of the 152 original research articles retrieved, 40 qualitative studies and 5 studies that were written in French were excluded. And then the remaining 107 articles, 92 of which were purely quantitative in nature, and 15 that were mixed methods, were then included. So we had 107 papers that Holly times two, the two grad students, went through for our checklist. So although other checklists exist to evaluate statistical quality, many are very design focused rather than statistically focused questions. So I'll give you an example. Um, to be really honest and frank, I feel that many checklists get a free pass sometimes. Was there a study objective? Check. Was the primary outcome clearly identified? Check. And that's fine, but those are, really should be in a given in almost every research study. And they're not, and they're ones where you can, sometimes get a 7 out of 10, but you're not really getting at a lot of the statistically focused questions that are really also pertinent to evaluate the reporting. So our checklist contained 12 questions, 7 of which had subsections for a total of 34 different items. 6 of the 12 questions were adapted from another paper, Parsons et al., and the remaining questions were decided upon by our team. And the checklist was designed in accordance with how a given rater or reviewer, call it what you want, would actually be evaluating a research article. So introduction, methods, results. Okay, discussion, we'll put aside because that a lot of course is their interpretation. So we stuck to intro, methods, and results. And the checklist questions were answered with a yes, a no, or a not applicable for 28 of the 34 items, and 6 were a written response. And this checklist was pilot tested before we used it by Dr. Holly Shafsma and Holly Lassinen on 10 different articles from various nutrition journals before uh, beginning the process in the Canadian Journal of Dietetic Practice and Research. So here's the two Hollies here. So these graduate students at the time independently reviewed all 107 papers, and the research team's biostatistician, that's myself, adjudicated any checklist items when they could not come to a consensus. So let's look at what we found in the 107 articles. Okay, so the 34 item checklist was applied to all 107 papers, and that resulted in 3,638 items completed by each rater independently. I will say this, a truckload of work, but again, we had great grad students, so it worked. Now, this was interesting. When we just started about reporting of objectives and design, the hypothesis or objective was clearly stated in the vast majority of studies. So 97%, 104 out of 107. However, the study design was only reported in about half of the articles, okay, with cross-sectional studies being the most reported design. So as we know, if we look down here at the kind of pyramid hierarchy of studies, there's nothing wrong at all with cross-sectional research, of course, but we have to be careful using cross-sectional research to imply causal relationships, right? Because it's much more hypothesis generating, exploratory, because we don't always know what came first, the chicken or the egg, when we're talking about outcomes and/or exposures. In terms of sample size, only 47.9% of the studies justified their sample size. And interestingly, only 21.2%, so about 1 of 5 studies that actually required a sample size and calculation included one. So why would a study require a sample size? Well, if they're testing a hypothesis, say between an experiment and control, and they require some justification of how they come up with the numbers that they did. And of course, when there's no justification of sample size and there's no power calculation, and lo and behold, the findings are null findings, how do we know that they had enough people in the study in the first place to actually test their hypothesis? This is the type 2 error, saying there's no difference when there could be. And interestingly, only 7 studies that conducted a sample size calculation, only 3 of them were adequately reported. Meaning, I'll give you an example, something like this. Uh, a pre-study sample size calculation was um, conducted, and we determined that, I'm just going to make up numbers, 45 per group were needed. That doesn't say anything about how the 45 were come up with. What was the statistical power? What was the effect size? What was the standard deviation? So there's no way of knowing whether that sample size calculation was adequate or not. In terms of sampling, we know that whenever possible, probability sampling, or sometimes called random sampling, is preferred over non-probability methods because when you have a random sample, you have greater likelihood that your sample is generalizable to a larger population. Yet only 15 studies, 14%, use probability sampling. 5 use some combination of probability and non-probability sampling, and 70% use non-probability sampling. Again, nothing wrong with that per se, but if you use non-probability sampling, be awfully careful generalizing your results to some larger population because you may not have a representative sample. When we looked at missing data, data were missing in 76 studies. That's 71%. And of those 76 studies with missing data, 1/4 provided zero explanation why data were missing. And of course, this is problematic if you have, say, 2 groups. Let's say one group gets counseling by registered dietitians, the other gets, say, usual care. And those in usual care, I'm just making this up, the people with the worst prognosis um, or the people with the worst prognosis drop out in one group. Well, what you often have is now differential attrition, where one group has a much higher likelihood of having a better outcome simply because people who are left in one group have a better prognosis. So missing data can threaten the generalizability of studies' findings and decrease statistical power, basically increase the risk that you're going to have a null finding, type 2 error. The Strobe-Nutt guidelines for nutritional epidemiology research suggest that authors, quote, report the number of individuals excluded based on missing, incomplete, or implausible dietary data. And keep that in mind when 25% of the studies had no explanation at all for why data were missing. In terms of even basic statistics like measures of central tendency and dispersion, of the studies that reported measures of central tendency, the appropriate measure was used 81% of the time. Okay? But flip that around, in 1 of 5, they didn't use the appropriate measure of central tendency. So they, for example, may have reported the mean instead of the median when the data was highly skewed. Or the data, they could have used the median when there was very little dispersion, and a mean would have been a more appropriate measure. And then a measure of dispersion accompanied the measure of central tendency in 72 papers, and 12 of which did not use the correct measure of dispersion. So I'll give you an example. As most of you know, the standard deviation is the appropriate measure of dispersion that accompanies the mean. But they may have, for example, reported the mean with the range, and that's not the appropriate measure of dispersion. Or they could have used the median and then they use standard deviation. So incorrect measure of dispersion accompanying the measure of central tendency. In terms of statistical reporting, 42% of studies did not adequately report their statistical tests. Now, this is a problem. Inappropriate reporting occurred when the authors, for example, didn't specify which statistical test they used. They reported results of tests that weren't even described in the methods. They omitted results of the tests described in the methods. They showed discrepancies between statistical report procedures that were mentioned in the abstract versus the manuscript, or they reported procedures so inadequately that neither Hawley, Shaftsma, nor Lassinen could even determine which statistical tests were used. So this is a problem. And then of the 281 statistical tests performed, 11.7, almost 12% were incorrect. Okay, so an incorrect statistical test, I'll just give you an example, could be applying a independent samples t-test to compare means between two groups, and the outcome variable was categorical, not continuous. Wrong statistical test. So this is concerning because inappropriate use of statistical tests can lead to a distortion of findings and possibly even discredit the conclusions drawn. Remember what I said at the beginning when I introduced myself? I said that if we don't know whether the correct statistical test is applied, and we just skip that portion of the results or the methods, and we just go to the intro, the tables, the figures, and the conclusion, what are we really fully evaluating in nutritional epidemiology? So this is where more training is really necessary. In terms of hypothesis testing, only 12% all round of the articles that tested more than one hypothesis did any type of adjustment for multiple comparisons. So, for example, if you're testing five hypotheses and you say that a p-value less than 0.05 will be used to determine statistical significance, well, that's a very liberal p-value. What you should be doing is some type of adjustment because you're testing five different hypotheses. Clearly, a very conservative one would be a Bonferroni adjustment, where you take 0.05 and divide it by five different hypotheses, and you say, this is the p-value we're going to use to determine statistical significance, given we're testing so many different hypotheses. So multiple hypothesis testing is common in research and poses a very serious issue because it increases the risk of a false positive, a type 1 error, which is basically saying that five times out of 100, when we say there is a significant result, it's false. That's what a p-value really is. Also, we found that the sample size was not stated in all figures and tables in 44% of articles that depicted participant demographics or statistical analyses. So what that means is, I'll give you an example. The typical table one, let's say we had 85 in one group and 85 in another group, and we have a nice demographic table, double thumbs up. But then, table three, you see some type of regression model and no mention at all of the sample size. Right away, I go, was everyone still included in the regression, or were a whole bunch of people list-wise deletion removed? And that's why you're finding null findings when it comes to the regression. So we need to be very transparent about sample size. In terms of p-value reporting, one study described a p-value greater than 0.05 up to 0.1 as statistically significant, and 9 described a p-value greater than 0.05 to 0.1 as a trend. Now, I know the latter point a lot of people do, and they'll say, what's wrong with that? But what you're saying when you say there's a trend, that was close, it was 0.08. What you're saying is you are close to 100% confident that with larger numbers, with higher sample size, that things will now lead to a statistically significant result. But you don't know that at all. More data might actually make things less close to statistical significance. We can't make that generalization. And in terms of changes over time, there was no tendency over the 10 years of the research towards improvement or worsening of the quality of statistical reporting or the statistical test procedures. Reporting errors were highest in 2018. We can see that with the 62.5% in Figure 1A, and lowest in 2016 and 2019. That's the 27.3%, for example, here in 1A. Total statistical errors were highest in 2019 and lowest in 2013. And the percentage of articles with at least one statistical test error was greatest in 2014. So let me sum this all up. The biggest strength of this evaluation was that articles from the Canadian Journal of Dietetic Practice and Research were assessed over 10 years. It's not just a single year or 2 years. A limitation is that our checklist was piloted but not validated. Also, even though our checklist was created to be as objective as possible, the raters were required to use some level of subjectivity when reporting was poor. And I don't really see that as a major limitation. If the statistical reporting is so poor, you're kind of left going, I think this is what the authors did. Based on the results of our statistical review, we encourage nutrition researchers to reflect on their level of statistics knowledge, potentially pursue additional training, or seek the assistance of a statistician as needed. Next, we suggest that all scholarly journals conduct a thorough statistical review of submitted manuscripts prior to publication. I know this is a very difficult thing to ask because in today's world, of course, we're bombarded with constantly, would you review a paper, review a paper, review a paper, and we take on what we can. But I do think that a journal has a responsibility to ensure that at least one reviewer has sound statistical knowledge to be able to actually evaluate the adequacy of the statistical reporting and interpretation of the findings. And going back to what I said earlier, the ability to critically appraise and conduct high quality research is essential to truly advance evidence-based practice in nutrition science. Uh, some of my affiliations, we're going to leave questions till the end. I think I'm only a couple minutes past. So thanks, everybody. I'll stop my share.